Okay, so we've been doing integration and differentiation with natural log and exponential functions base E. Well, today we're differentiating, integrating with exponential functions other than E, not E. So 10, 5, other than E. So this slide right here is just to remind you that, well, first of all, you have the differentiation rule. The differentiation rule for logarithmic functions base A. So base A means any base. Any base is the log base A of x equals 1 over natural log of A, natural log of x. That's the derivative of it. Blah, blah, blah. So, again, base is in the basement. Yes? Mm-hmm. If A is a positive real number, that's just all that kind of stuff. Now, at the bottom, this are just our rules. Remember our log rules? So if I want y equals a to the x, that's x equals log base a of y. So I will be changing my exponential into a logarithmic so I can take the derivative of it. See that? So when I know my inverse property, if I have a to the log base a of x, the answer is just x because the bases match, a and a. If I have log base a of a to the x, again, my bases match, so the answer is x. Those are rules we used last year, didn't we? And then down at the bottom, log base a of 1 equals 0. We've discussed that. When it's multiplication, it's what? Addition. When it's to a power, I can bring the power out front. All the same rules used on natural log, but we're now using them on any log. Tell me when you're good, Riley.
I'm good.
Okay. So now it says solve. So I'm just going to solve. So I can't get to the x. So I'm an exponential. I need to put it into what?
Logarithmic.
Logarithmic. So it's log base what?
Log base x.
Nope, log base 3 of 1 over 81 equals x, right? Mm-hmm. Okay, but now I got to solve that. So when I'm doing this, 81 is 3 to the 4th, correct? Mm-hmm. But it's in the denominator. I want to bring it up to the numerator. So what do I put? Negative power?
Yes.
So I have log base 3 of 3 to the negative 4th equals x. So, but log base 3 of 3 have the same bases, don't they?
Yes.
So x equals
negative 4.
Negative 4. So that's just using our properties, isn't it?
Mm-hmm.
Okay. So in the next one, I'm in logarithmic. So now I need to put it into what? Exponential. So it's log base 2 of x equals negative 4. Well, now we have 2 to the negative 4 equals x. Well, 2 to the 4th is what?
32.
No, that's 5th.
16.
16. 2 times 2 is 4. 4 times 4 is 16. But the negative puts it as what?
1 over 16.
1 over 16x. So that's just some review. So then some of your problems are just going to be review of that. But you're going to have to use this to be able to take the derivatives. Make sense?
I think what's just going to give me is like transforming them, like let's say exponential transform it into log.
Right. And I think because I'm not going to be here tomorrow, when you look at your answers on Calc Chat and stuff, I think that will help you because you'll see enough of them. They'll do it for you. Like you'll get there. And actually most of them you have our odds tomorrow. Like anyway. I would start tonight so you're not trying to get it all done tomorrow. Okay. So derivative base E other than E. Here's our rules. The derivative of a to the x, I touched it. The derivative of a to the x, so that's any base, not E, okay, is the natural log of a times a to the x. Second one is a to the u. Remember, u is like x plus 2 or 2x. It's not just a number, right? Or not just an x. Is the natural log of a times a to the u. And if it was me, I would not put du dx. What have we been putting?
Prime.
U prime. So, and I don't like the order it's written in. Can I write it in a different order?
Yeah.
I write a to the u prime, natural log of a. I like the natural log of a at the back. So if I have log base a of x, the derivative is 1 over the natural log of a times x. And again, if it was me writing it, I would write x natural log of a. Hate it written like that with the x behind it. Doesn't it bug you guys? I don't know. It bugs me. And the last one, I'm going to rewrite it for you. So we have 1 over u natural log of a times u prime. Now I'm going to tell you that a lot of times you will see u prime over u natural log of a. Now, you guys have seen u prime over u, correct?
Yes.
That was for the natural log, wasn't it?
Yeah.
And then when it's any other base besides e, we just add that extra natural log of a in it. So those are your rules. Make sense? Okay, so I need to find the derivative of 2 to the x. So 2 to the x just fits derivative rule number 1, doesn't it? Okay, so it would be y prime equals, well, a to the x, which would be 2 to the x, right? Natural log of a. What's a?
Wait.
The rule's a to the x. So what's a?
Natural log of
No, isn't a 2? Look at it, guys. Of 2 to the x. So a equals 2. So 2 to the x times natural log of 2. That's it.
Why is the y prime just 2x? Like,
No, y prime is because it's a to the x right here.
I know, but did you like the derivative of?
The derivative of 2 to the x, so y prime, is 2 to the x times the natural log of 2. That's what it is. So on the next one, I have y equals 2 to the 3x. So I have a u, don't I? What's my u? 3x. So that's going to be this rule right here.
Yes.
And I need u prime. So what's u prime? 3. Okay, so now I just need a to the u. So y prime equals a to the u. So 2 to the 3x times u prime, which is 3. And then natural log of a, and a is the base, so natural log of what? 2. Now, I cannot multiply this 2 and this 3, can I? No. You could write it 3 times 2 to the 3x natural log of 2 if you'd rather put the 3 in the front. Sometimes I would, but does it really matter? Nope. What matters is you can't multiply that 2 and your 3, can you? So you're going to find which rule it meets, and you're just going to do it. Am I making sense?
Yeah.
Okay. So, integration, here it is. Integration of a to the x dx is 1 over the natural log of a to the x, or I would just write it a to the x over natural log of a plus c. Doesn't that look better?
Yeah. And it's, yeah.
And again, guys, it's just, what is a? I've got the integral of 2 to the x dx. What?
Number that's not like
A is the base, right? So in this one, A is what?
2.
2. And A to the X is what? 2 to the X, isn't it?
Yes.
Okay, so I'm just going to fill it in. So it says A to the X, so that's 2 to the X over the natural log of A, so the natural log of 2 plus C. That's it. That's all I got.
So wait. So a to the x, we just added an x to the top.
No, I didn't add not. That's what it is. A to the X is right here.
Oh, I thought the x was down below.
No. Nope. Any other questions? Because that's it. That's all I got.
Okay.
I think. Shelby, tell me when you're good. But I think that's my last slide.
I am good.
Yep.